Okay. Well, let's get started. So, James, what was your question?
I think I saw it.
All right, fair enough. So my plan is to do data modeling, which is what people were requesting. So, and I wanted to use a whiteboard, but actually I just expected the whiteboard that was over there to be here, and it doesn't seem to. So, Jared, the whiteboard thief. Okay. Okay, thank you. Right. And then I will start to record as soon as. It's going to be about SQL schemas and data modeling. Thank you very much. I appreciate that. All right. Cool. So let's just start. Just start on the whiteboard. And I will record this, but I can't record it because I am not the meeting host. Okay. So what I'm going to do, let's see who we have actually on. Okay, so Latoya, would you be willing to come here instead, just because I can't record on this particular Zoom. It says recording. No. And you can get rid of. Is Jared recording it? Well, okay. All right, neither do I. Well, if it doesn't get recorded, it's not, it's not a disaster. So, okay, yeah. So let's talk about data modeling and schemas. So like, what is a schema? Skeleton of the database. And so, what's it going to include? What the tables? Yeah. I heard him hear that last tables and how they're going to be related to each other, right? And it usually includes all of the columns in each of the tables as well. So what? Let's see. So what does a SQL table mean? Sorry, can you not even hear? Yeah. Okay. Thank you. What does a SQL table mean? It needs a name. Okay, good. So, and when you draw out the table, you usually put the name like in a rectangle on the top. So I'm going to call this one employees. Okay. Different columns. And usually there is one particular column that every table needs. Yeah. The primary key. And what are the two requirements for the primary key? There are two requirements. It needs to be unique. And what did you say? Yeah, it needs to, okay, so unique. And then, and what else? No, you can have a primary key that's not serial. It often is, but you can have one that's not. So yeah, so it needs to be unique, and there's another requirement. If you have another table that has a foreign key, usually the primary key serves as that. We'll talk about that in a minute. Yeah, Keith?
It needs to be an integer?
Can be words. We'll talk about that in a minute too. This one may be so obvious that you're not thinking of it, but it also can't be null.
Oh yeah.
Yeah. So it is a unique identifier for every row. It has to be unique for the row, and it can't be null. So you can have a row that has all of the same columns in it, all of the same values for each of the columns, but you know that that primary key is going to be unique. You should never have a table without a primary key. Cool. So here, what do you think we would use for our primary key for our employees table? Employee ID. Okay, so we can just say employee. There are different schools of thought as to whether to use snake case, which is with this underscore, or camel case for column names. I prefer snake case. Okay, so we have the employee ID, and then we're going to put a star here to indicate that it's the primary key. Okay. What else might we want to record for the employees?
Their name, first and last name.
First name does not need to be unique, right? Last name also does not need to be unique. What's that? Start date, yeah, great.
Department meeting.
Department. Latoya, it's like you're just playing right into my hands here. Okay, department. Now, first name and last name, there's really no value in keeping those in another table. We do not need to say that there's just not going to be enough overlap for first name, so we don't have to have like a table of first names. And then we put like Latoya and James, and you know, that's 1 and 2, and then use like the first name ID here. There's just not a lot of benefit in that. But there might be a benefit in having department in another table. What might the benefit be of having department in its own table?
There's multiple and employees. Can they kind of overlap sometimes?
Yeah, and I mean they could, but employees could overlap in names too, right? We could have 2 Jameses.
Yeah.
Departments aren't going to change much, definitely. But there's another reason why we might want to give departments its own table. And that is that departments are going to have sort of metadata associated with them, right? They might have a phone number, they might have a department head, they might have, you know, and that is something that we don't want to have to repeat for every employee. Right, we don't want to put who their department head is. We don't want to put what their department phone number is. We don't want to, you know, instead, we can store all of that in departments table and just have a reference to it. Does that make sense? So department is going to be a foreign key. And sometimes that's indicated with an underline. So this is going to be a foreign key. And so now for departments, oh, and for the employee ID, by the way, let me back up just a minute. We're going to make this one serial, which you mentioned before, Latoya. We're going to say our first employee is just going to get number 1. Our second employee is going to get number 2. We aren't going to actually give it what the employee is or what the ID is. Okay, but for so for departments, what might we have as the primary key for departments? You could have department ID, but one of the things that I wanted to just to give you a different idea, we can also do a department code. And that way, instead of like having department 1, department 2, department 3 as the unique identifier, we could have like engineering and marketing. You can. Primary keys don't have to be numbers, just as long as they're unique. Okay, so we'll have a department code, and we'll have phone number. Fine. For now, that'll be it for our departments. And what is the relationship between departments and employees? So your choices are one to many, meaning one row in the employees table might be associated with many rows in departments, or vice versa. Many to many. Or one to one. And one to one is rare. Okay, so what do you think? From employees to departments, yeah, what's the relationship between these two tables?
Yeah, do it now. Even if you just give them putting it to work, you now know how to make it easier.
Yeah, so the big question is, can a department have multiple employees? Absolutely. We can do this. This is called a crow's foot. We can say that one department can be associated with many employees. Can an employee be associated with many departments? In most cases, not. Do we want to allow for that possibility? Okay. All right. Let's keep it simple, but then we'll talk later about how to allow for that possibility. But for now, we're just going to say department code here. And again, let's see. It's common to use ID if it's a number and code if it's a string. Okay, so we'll have department code here, which is our foreign key. I'm doing with an underscore here. Okay. All right. One department, many employees. One to many relationship. Cool. Any questions on this? All right. So should we code it up? Can you see the screen okay? Okay. All right. So, all right. Thanks, Jedi. Okay, so let's, I do not need to see myself here.
What's the topic?
Talking about SQL schemas. Okay, so let's actually do it inside a text document. And I'm going to call this, let's go here, and I'll make a new folder, and I'll call this, and then I'm going to save this as, my company.sql. Okay. So here it's mycompany.sql. This thing is really just kind of in the way. And it is going to have SQL syntax highlighting, so that's great. Okay, so I need to create two tables. So I'm going to use create table. It is common to have keywords in SQL be capitalized. It is absolutely not required. But at a job interview, I would recommend it because it makes you look like you know what you're talking about. All right, so employees. And I have not really memorized this syntax. And the reason is creating tables is something that's actually very rare in the life of a software engineer. It's essential that you know sort of the theory behind it. But because I don't do it very often, I just don't have the syntax memorized. So I have a little, I have this up here for me. All right, so create table whatever, the column, the data type, and the constraint. So the column name, we said we were going to do employee ID. The data type is going to be serial. You actually don't have to tell it that it's an integer. You just have to say that it's serial. And then I'm also going to say it's a primary key.
Um, yeah, well, the serial is going to take care of, that says it's both an integer and it's auto incrementing. It takes care of both of those for me. Okay, and then what else did I have? I had a first name, and that one, there are different schools of thought as to whether to make it a varchar, variable character, and that would be like, then you would give it a number of characters. So I could say like 50. Or you could, you can also do things like text, which is a little bit more general. Different schools of thought. We'll use varchar here. And let's see, do I have any constraints on this? Do I need it to be unique? Do I need it to be not null? Yeah. Okay, we'll do the same with last name. Okay, and then there was a start date, right? That one is going to be a date time. And I'm going to make a default. And I want the default to be now whenever I create the record. So let's remember how to do that. So let's just do a quick Google search for SQL. Here, I'll do it here so you can see. SQL, no, apparently not. SQL date time default now. Okay. Sure. Now that I'm seeing this, I think it is like you use default current date. Although this one, oh, that's, yeah, this is the one I want. Default current timestamp. Great. And then the department code. And that one I want to have as a foreign key. And what do I get? What do I buy by making that a foreign key? Yeah, I could though. I mean, if I just said department code was a varchar 4, I could totally make an employee that had a department that was, engineering, right? What advantage is it to making this a foreign key? There will be the same column in both tables, but even more than that, this is what it produces, what we call referential integrity. Referential integrity means two things. One, I can't put a key, or I can't put a department code in the employees table that does not exist in the departments table. So foreign key must exist in referenced table. And the other is, Adam is trying to help me out here by capitalizing table for me. Thanks, Adam. And the other is that you can't remove a record in the reference table if it's referenced in the other table. It's really not all that well put there, but like if I try and delete a record, it won't, SQL won't let me if I have designated this as a foreign key and it refers to something in the other table.
So you can't delete it from table A, but can you delete it from department table because it's the primary key?
Yeah, no, so let me if and I'll do an example of this, but if I have an employee who is in the marketing department, I am not allowed to remove the marketing row from the departments table, because that violates referential integrity and SQL won't allow it. So that's what I get when I make something a foreign key. All right, and so how do we make it a foreign key? I don't know, I never make tables, but let's look and see. Okay, So you say foreign key, then person ID references the table and the name of the column in that table. Okay, so foreign key, and we'll call it, oh, it looks like we'll do foreign key department code. I've also seen it with department code first. References departments, which doesn't exist yet, and department code, which also doesn't exist yet. Okay, so cool. Let's create our departments table now, which maybe we should have done first since employees depends on it. Okay, and so now we've got department code. Notice I did not have to say what data type this one is. It references the department code here, so it's going to be whatever this department code data type is. So I'm going to say varchar 4. That I'm also going to say it's the primary key. So what does it mean that it's the primary key? What are the two things? Unique and not null. Okay, and then phone number. And we'll make that a varchar. Yeah, make it a varchar of 7. Well, they're on the, well, no, we should do. Maybe they're not all in the same city. Does that need to be unique or not null? Let's call it not null. Maybe who knows whether or not it's unique. Maybe marketing and sales share the same. I don't even know how it all works, but not unique. Wait, hold on. Not null. Okay.
I also noticed that your syntax is a little different in W3 schools. Like does that matter? Or
The semicolon definitely matters.
Okay.
SQL is not, it's not like JavaScript where semicolons are optional. But the parentheses are not. I don't think the parentheses are necessary here. We'll see. Yeah, it's a good question. I think that the way I've done this in the past, I've used a different reference than W3 schools, and I think that that I actually do it this way. So we'll see, or that this is the way that I've seen it most often. Okay, but we definitely, yeah. SQL, if you don't have the semicolon at the end, it assumes that there's more coming on the next line. So, okay. So let's try this and see what we get. Okay, but actually first, I can't do this until I make a table. How do you make it, or until I make a database. How do you make a database? And let's just call this my company. Right. This is something I have to do for my presenter user, but I actually did, I'm my Bonnie user, and so I'm using now Oh My Zush, which is why I have like my fancy prompt and everything. So let's, okay, great. And now how do I access that? Say that again? Oh, if I was inside Postgres, absolutely. But I can actually do a shortcut, and I can just say, and no, apparently I can't. So I can do pSQL My Company here. And now I'm actually in the My Company database.
Yeah.
Okay. Oh, and actually, right. I was going to copy and paste, but actually we can do something else. If I didn't I? Oh no, I presenter source. This might get messy, but let's see. Okay, so. Okay, so now I can do pSQL, and I want to use that database, so I can, and that's right, you guys do it a little bit differently here, but for now, this is what I'm going to do. So My Company, And I'm going to run all of those commands in my company SQL inside that database. Didn't like it. Okay, so it didn't like, oh, well, it didn't like my referential integrity comment. So let's first just comment that out. And then it looks like I'm missing some punctuation between here and here. So let's go back and check my, okay, so I need some parentheses around my columns. Like I say, something that is good to know how to do, but that I do so rarely that I just don't have the syntax memorized. Okay, so let's try again. It didn't like that either. So let's first try putting it back in the order. And I'll just put the parentheses there too, since, all right, try again. Date time does not exist. Okay, so we're using Postgres here. So let's just, let's do some Postgres date time type. Let's see what we get. Okay, so I have to use timestamp with Postgres. We all good? All right, what do you guys think the chances are this is going to run? Oh, well, apparently it sort of, except for the date time, it actually made, all right, so referenced foreign key constraint does not exist. So we have to make sure that we create our departments table before we create our employees table. Otherwise, it just doesn't know where to get this departments table. So, and now, oh, no, it's still, okay. So first I just want to, referenced foreign key constraint does not exist. Department code. All right, let's go back. So this is MySQL. This is server. Oh yeah. So yeah, notice that. Okay. So it doesn't actually say which one for Postgres, but I'm guessing it's actually this one that I'm more used to seeing, where you actually do have to, sadly, you do have to give it the type. So we'll do varchar 4 just to keep it consistent. Okay. All right, let's try again. And let's drop DB. I'm just going to drop the database and make it again, so that I'm not going to be recreating any tables that already exist. Oh, no, wait, hold on. That's not the one that was hard. Okay, let's try again. All right, so now I'm giving up on W3 schools, and I'm going to go straight to the source, and I'm going to do Postgres foreign key. Okay, so it's just references. You don't put the foreign key in. And I think, yeah, okay, so it does put the column in. I think you might be able to skip the column just because, like, if it's just going to be the primary key. But okay, so let's go back. Try one more time. Why not? Okay. Yeah, because it had already created the table, I actually think I'm okay, but just for good measure, let's drop the database, create the database, and okay, all right. All right, so now we have 2 tables, amazing. All right, so let's go into Postgres, and let's make some employees and departments. We need to make the departments first, right? Otherwise, when we try and make the employees, we're going to get referential integrity errors because their department codes won't be in the department table. Oh, but you know what? Just because it's a foreign key doesn't mean that it's not null. So I actually want to put a not null here, just so that I know that everybody has a department. Otherwise, you could make an employee without a department. Just because it's a foreign key does not mean it's automatically not null. And okay, so let's go back here. Backslash commands in Postgres, so \q gets you out of here. And let's just okay. So if I want to look at my tables, how do I do that? Yeah, but in this version, in Postgres, you do a \d and the table, which is employees. Okay, so here it's telling me it's got the employee ID, and it's got this next val employees C blah, 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 blah. This is the serial part. It has the first name, the last name not null, the start date defaulting net to now, the department code not null. We've got this constraint that the department code references the department's department code. And then we actually have an index on the primary key. Primary keys are indexed by default, and I'm not going to talk more about indexes now, but basically it means that you can find things more quickly if they're indexed. Okay, so you can search the table more quickly on indexed columns. All right, and then we have departments. Okay, so we've got the code, the phone number, we've got an index on our primary key, and then notice that it also references, or it includes that it's referenced by the other table. And that's important for that referential integrity, for SQL to be able to check, okay, before I delete a row from the departments table, I have to check and make sure that's not being referenced by this other table. Because if it is, I can't delete it. It's going to violate referential integrity. Okay, so so how do I get a department into the departments table? Insert. Then what? Into. Then what? Yeah, the columns I want to insert. In this case, I am going to be inserting both columns. So I don't necessarily have to do the columns if you're doing all of them, but it's definitely good practice. It's a good habit to get into. And then values. So marketing and let's see, 10 characters. So marketing is going to be 510, 555. Okay. Oh, is it in there? Semicolon. If you don't get any response, it probably means you forgot the semicolon. No, yeah, because white space doesn't matter in SQL, so you can have as many returns as you want. Okay, yeah. So now how do I check to see if it's in there? Yeah, and I can do a select star, and there's my marketing. Okay, and now let's just put engineering in there. And let's put legal in there. and they all have the same phone number, whatever, it doesn't matter. I didn't have a unique constraint on that. So, okay, and so if we do the select star again, great. So now if I want to make an employee, let's look at the employees table again. Okay, so I'm gonna give it a first name and a last name. I'm not gonna give it a start date because it's just gonna default to now. And I'll give it a department code. And I'm not gonna give it the employee ID because that it'll pick up automatically with serial. So let's insert into employees, first name, last name, and department code are really the only things I need to give it. And so let's do the values. And I'll say Mary McMahon, and she's going to be in marketing. Okay. So there I've got Mary. She got automatically, she got the start date, and then she got the employee ID 1. Okay, and then we'll do somebody in legal. What did I do for legal? LEGL. And we'll put Larry Loser. Okay, and so now I have somebody in legal, and we'll put into engineering. Now let's say I forgot, and I thought that engineering was ENGI. What's going to happen here? I'm going to get an error because engineering's not in departments. That's what the foreign code buys me. Whoops. Okay, cool. So now, all right. Oh, interesting. Those mistakes actually took up keys. That's just a quirk of Postgres. They took up IDs. Okay. All right. So let's say Larry leaves legal, and we want to remove him. How do we do that? Delete from employees. And here you definitely want to use the primary key. We don't want to say where first name is Larry because then it's going to delete all of the Larrys in our table. So we'll say where employee ID is 2. Deleted 1. If we look at employees, he's not there anymore. Okay, so now if we want to delete the marketing department, delete from departments where department code equals marketing. Can't do it because it's still referenced in employees. Okay, questions about anything that we've done so far?
What was the on the commands? What was that \D?
The \D is for describe, and then you give it a table, and it shows you the table.
This is a little bit more of a meta question, but like in a production environment, who is the person that actually is like creating the table?
There is a database architect usually in a large company, And so that database architect is the one who designs the database. And if engineering needs a new table, the database architect will like make the new table and make sure that everything is okay. Or sometimes you'll just have the database architect at the beginning, and then the engineers themselves will be in charge of making new tables. But in general, databases are pretty static. Not the data in them, but the schema is pretty static. Usually you make a database at the beginning, and then you make as few changes to it as possible, which is one of the reasons that you want to think really hard about your database at the beginning. Even adding a column to a large table, which is called migrating, can be incredibly time consuming and costly. So yeah. So in general, you don't want to change. Adding new tables isn't as big a deal, but changing existing tables is generally only done in emergencies or for really good reasons.
Went to like a big data talk, and there was this lady there. She was giving a talk on the big data. And she had interned at Microsoft or one of these big companies, IBM or someone. And she was saying that like literally they have one database that everything is on, like one table.
One table?
Yeah. So
wow, okay.
one table.
Sometimes if there are no relationships, it's just not necessary to have other tables. Yeah.
Yeah, it's a really old.
Okay, and then I use Q to get out of here. This is a paging system. It's either less or more, and so I just use Q to get out. Just type the character Q on the table. If you do a -DT or \DT, it tells you what your tables are.
Is that Postgres specific, or is that the same?
Yeah, it's Postgres. Yeah. Yeah, in MySQL it's different. It's what Miro was saying. It's describe and then the table name and then show tables if you want all that. It's different. Yeah. And notice these / commands don't have to have semicolons at the end. It's just, they can, but they don't have to. Okay. Let's talk a little bit about many-to-many, as long as we're talking about databases here. Many-to-many. So what if somebody could be in both the legal department and the marketing department? How would we deal with that? Okay, so you could have department code 1 and department code 2. What if we didn't know how many departments somebody could be a part of, right? Then what if somebody could be up to 4 departments, and we say department code 3 and department code 4? What are the disadvantages of this? Yeah, you're definitely, like, most people are in just one department, so why do we need to, like, have all of these here? What's another disadvantage? What if somebody is in 5 departments? You have to migrate this table. You have to add a whole extra column, and that is not a simple thing to do if you have a lot of employees. So, many-to-many is a bit of a lie. Tables do not have many-to-many relationships. If you have 2 tables with a many-to-many relationship, you need a table to manage the relationships. It can be called a middle table or an association table. And you can call it employee departments. There are different ways of naming this, but this one we'll just say employee departments. Okay, so now we have, and here, this is going to have an employee department ID, because every table needs a primary key. So this is just giving you the uniqueness of the row. And then you can have an employee ID and a department code. And both of these are foreign keys. So now I can have as many associations between employees and departments as I want. Each of them has a record in the employee department table. So if you're going to have many to many, you need an association table. Sometimes the association table, this one, all the association table is doing is serving as the glue between the two tables. Sometimes the association table might actually have information, right? If this was movie reviewers and this was movies, then this could be reviews, because each reviewer can have many movies and each movie can have many reviewers, right? So it's a many-to-many relationship. And then this table could actually be reviews, and it tells you who the reviewer is, what the movie is, and actually what the review was, right? So this table can have data in it. It doesn't really need it for our little schema. Okay, so now I'm just going to get out of here, and let's create a database, my company 2, and let's go here, and I'll save this as my company 2 SQL. Okay, so now we have departments, we have employees, and I'm going to remove this line here, and I'm going to create table employee departments, and I can say emp dept ID, and that's going to be a serial, it's going to be a primary key. Okay, and then it's going to have my department code. All right, now let's see if I can remember. References, oh no, I have to give it varchar for references, departments. No, hold on. Let's just not. References, okay, yeah. And we'll make that one not null. And then we'll do the same thing here. And this one, I'm going to say integer, because you can't really say serial for a referenced one. So let's say integer. Okay, so now okay, is that cool? All right, so let's try it. All right, we have 3 tables. And so now if I look at my tables, there they are. And so now I can insert into employees, and I'll do first name, last name, oh no, I'm not doing department code anymore. So I'm just going to do first name and last name. Okay. And then I insert into departments. So department code and phone number. Let's see, I don't remember. And that one, I'll say How'd I do there? Not so good. All right, and now how do I associate Mary with marketing? Yeah, so I called it employee departments. And I'll give my department code and employee ID. And I happen to know that Mary is number 1, so. Good? All right. So now, let's see, then departments and department, or employee departments, is that what I called it? Okay. All right, so now, so the advantage now is that we can very efficiently store people who are part of multiple departments. The disadvantage is now we can't get any interesting information like who all of the people in marketing are without doing joins. So for the last 7 minutes, I'll just talk briefly about joins. Let's just make a few more people. So we'll make Mary McMaster in employees, and we'll make okay, and then I'll insert into departments. Engineering. And now I'll do some association. So let's see. So Mary McMaster is also going to be in marketing. I'm using 2 there just because I know with the serial she's going to have employee ID too. And let's say Mary McMaster is also in engineering. And then Ellen Excellent is also in engineering. All right, so let's go back here to construct our query because it's not that easy to construct queries in the if you want to make changes. So if I want, have you guys done joins before? So if I want to know everybody who is in the marketing department, what would my query look like? Yeah.
Select from employees.
Okay. Now, I can't really join on departments because employees and departments don't have any columns in common anymore.
Join employee ID.
Yeah. Well, what I really need to do is to join on employee departments. Oh, thanks. Because those are the 2 that have the columns in common. Employees, if we look, employees has the employee ID, and then employee departments also has that employee ID. Those are the 2 that we have to join. I like to do aliases because then I can say I want E first name, E last name, So I want the first name and last name from employees, join employee departments. Oh, I have to do an on. Where the employee IDs are the same. So that's how I would get information out of this schema. I want engineering. I want legal. All right, questions? Cool. You're welcome.